Geometry lesson 7-4. Today we'll finish our third transformation. We've spent time dealing with rotation and reflection, and today we talk about translation. As with the other two, translation is an isometry, meaning that when you slide something or glide something to a new location, you will not be changing its size or its shape. It'll stay, everything about it will be completely congruent to the original pre-image. Alright, Theorem 7.5. Now, this one sounds a little crazy, and it states that the P double prime, is going to be perpendicular to K and M. Now, I've got some diagrams over here that I'm going to show you. And the distance from P to P double prime is going to be the same as 2D. And D is the distance between the two lines. So let's say we have two lines, K and M. Alright, and from P, which got reflected again. So one reflection, two reflections. So this was the first image, that was the second image after the second reflection took place. This same object sliding over. Now you can figure out how far it slid just by looking at the distance between your two lines. So even though it's flipped and flipped is two reflections, the distance here is telling us how far it's actually moved according to the translation. So say between the two lines is 10 inches, then to flip and flip is going to mean a translation of 20 inches, twice as far. So that's what this theorem is stating, which is somewhat similar to what we spoke of last time, where when you reflect and reflect across two lines that are intersecting, it was actually a rotation. So two reflections created a rotation. Here the lines are parallel, so two reflections equals a translation. A vector, and I always joke about this from the old airplane movie, that's a Roger, Roger, what's your vector, Victor? A quantity that has both direction and magnitude. Now magnitude is another way of saying size. We use an arrow to represent between 2 points. So quantity with direction and size, all right? Both of those. This is what our vector would look like. We don't use a full arrow, it's kind of the little half arrow, and you would call this vector R to W. And that's very particular. The R and the W are telling us lots of information. We have an initial point, R, where it starts, and that's what we would call the starting point, is the initial, when it begins. And then we have the terminal. When you come to the terminal, your trip is over. When you have a terminal disease, if an animal is terminal, it means it's going to be dying. It's the end. So terminal means the ending. So we have a terminal point of W and an initial point of R. So we're starting at R, ending at W. And that's what we refer to as a vector. And this is probably the last thing we're going to cover that's a little bit confusing for people when they see it. This is known as component form. Now these are not parentheses, so be very careful about that. It combines the horizontal and the vertical components. In other words, the change that's taking place horizontally, that's left to right, would go here. And the change that's taking place vertically, that's up and down, would be here. And we create this coordinate, but with our inequality signs, basically. It's not parentheses. All right? So if a shape starts here, and we call that A, and it ends up over here, call that A prime. If it goes up 4 and right 3, then you would have a horizontal movement of 3 and a vertical movement of 4. So you would not have 4, 3, you'd have 3, 4. So this would look like this for our vector, and we would say 3, 4. And that would be component form for this vector. And that's the magnitude, it's giving our direction, and it has the amount that it's being changed by horizontally and vertically.